Hey everyone, thank you for joining the first community call for MIP6. I'm Harish. I work with Owen Labs community team. The purpose of this call is to invite the author of the MIP. Today we're joined by George to discuss the details of the proposal and let anyone ask any questions which you might have. So I'd like to bring on George. Please take the wheel.
Yeah, thank you, Harish. So yeah, let's talk about this MIP. This is MIP number 6, and it's called it's about reducing slot time from 3 minutes to 90 seconds. So let's talk about details of this transition. So we start with the impact. Oh, I'm sorry. Yeah, we'll start talking about the impact of this change before going into details of the actual change. So first, the impact of this change is that finality of the chain will be much faster. We'll have blocks being created twice more frequently than they are created right now. And also that impacts, for example, confirmation times for transactions, because it boils down also to the frequency of blocks. So network capacity grows as well, and by that I mean number of transactions that the Mina blockchain can process in a unit of time doubles if we talk about just regular transactions. But if we talk about the cap transactions, it actually goes tenfold, because for every block we'll have potentially 5x, 5 times more the cap transactions. And we have blocks twice more frequently. So this is a huge increase. And finally, this proposal doesn't affect economics of Mina blockchain, like no changes to tokens or rewards, and so whatever parameters were affected were adjusted accordingly to have zero economic change. So let's talk about details of this proposal, about technical details of this proposal. So let's compare what is going on right now and what will change after this proposal is fully implemented. So in the current system, we have block created at most once per 3 minutes, and this 3-minute time is called a slot. So we'll change that time from 3 minutes to 90 seconds. So it doesn't mean that, as previously, it doesn't mean that we'll have block every 90 seconds, and we didn't have block necessary every 3 minutes. This is not how our consensus works. But the time frame with each, at most one block can be created, squeezes from 3 minutes to 90 seconds. And that change alone means double increase in frequency of block creation. So then, apart from just changing from 3 minutes to 90 seconds for the slot, this proposal also suggests to remove the soft limit, the CKApp transaction soft limit. So this is a configuration. It's not a part of the protocol itself. It's rather a default configuration for the block producers. And at the time of Berkeley, it was set to 24 transactions, the cap transactions per block. So in this, when introducing this change to the slot time, we will also remove that cap, and that will enable block producers to include many more the cap transactions if these are available. So yeah, this is pretty much the core of the change that this MIP introduces. So let's talk why we decided to introduce this change right now. 180 slots slot time, 180 second slot time it wasn't perfect even before. So why now we decided to change that? So previously 180 second slot time was decided not randomly. It was based upon observations about how much time it takes to create a block, and not just an average block, which is much better, but for an edge case, for the worst case, block creation could take more than 100 seconds. And for that reason, we had 180 second slot time. Not only for that reason, there are a few other things that contributed to it, and we'll talk about that later. But the main idea is that even when we were delivering Berkeley and also when we had original mainnet, we had a number of performance, like performance of a number of routines during the block creation was much worse than we needed to reduce the slot time. And now we delivered a number of optimizations that enable us to cut the slot time. So this optimizations, they are listed in the full text of the proposal. But in short, block creation reduced to slightly less than 30 seconds. And a number of other things were also optimized. So we feel assured that reducing to 90 seconds will not impact safety and reliability of Mina network. And just as I mentioned, we suggest this change, this proposal in such a way so as not to impact the economic part like of the Mina protocol. So in particular, this is about block rewards. So every block created contains a coin-based transaction, and that transaction goes to the creator of the block. So this is I guess it's the only source of inflation in the Mina blockchain, if I recall it correctly. And because we adjust frequency of block creation, doubling the number of blocks per period of time, we also cut the block reward 2 times, so that proportions of how frequent are blocks and what is the coin-based reward, this proportion remains the same. And end of the day, that means that like staking block rewards, which are then converted into staking returns, they remain unchanged, and same goes for the token inflation. So yeah, let's talk about a few other implications of changing the slot time. Epochs will be shorter, and like previously, one epoch was around 15 days. Now one epoch will be just over a week. And that means that when someone changes their delegation, effect will take not up to a month as was previously, but up to 2 weeks. And also this will have effect on how stake pools distribute their rewards. It's still up to stake pools which reward schedule they prefer, but very likely that this will be affected by us changing the duration of the epoch. But overall, network governance, as described as described by the consensus protocol, will move at accelerated pace because blocks are twice as frequent. And special mention here, actually 2 special mentions on this in the next slide are about some technical details of proposal. And first of these technical details is about vesting accounts. So this is a feature that was originally used during the initial token distribution. But also we have this feature as part of the CAP framework. And vesting accounts allows the caps to be structured in such a way that the ZCAP account will hold certain funds and will release certain funds according to a specific schedule. So this is helpful for a few use cases. It is not widely used on the mainnet, but because we have this protocol feature, we need to take that into account when planning any upgrade to the protocol. And with change of the slot time, there is one specific effect, and this is about that vesting schedules are usually expressed like for the application logics, they are considered in relation to real world time, but they are expressed in the number of slots. And for that reason, this proposal provides a specific formula, which we'll include in the upgrade process. And that formula dictates how we change the vesting parameters of each account. And that formula ensures that if some account was to be vested, like such an amount of Mina was to be vested by that date, it will remain the same after the hard fork. Yeah, this is approximately the solution for the vesting accounts. And another interesting detail is about snark worker optimization. So this is not really part of the hard fork. This is a feature that we are finalizing work. We are finalizing work on this feature, and we plan to deliver this feature before the hard fork, just as a regular release. But this is important that we deliver this feature before the hard fork. So why it is? So previous 180-second slot time was dictated by a number of concerns, and one of these concerns is how much time it takes to process the max cost transaction. Yeah, currently these are processed in the blocks of 2 transactions, and to process such a block of work for a snark worker, it takes approximately 2 minutes. It depends on the hardware, but 2 minutes is a good number to refer to. With such settings, we cannot really go below the 180 seconds. So what we are implementing right now, and what we'll deliver before the hard fork, is an optimization that would allow snark work coordinators to distribute work on a single batch of work, which was previously taking around 2 minutes. Now they will be able to distribute it among a number of workers, so that parts of this batch of work are processed independently. And using this technique, we can see up to 6x reduction in the processing time for snark work for a transaction. So yes, we are delivering this change before the hard fork. It will have one particular impact, that some coordinators will need to run like 4 or more workers for optimal performance. And what I mean by that is that it is not necessary for every snark work operator to run 4 workers, but at the moment of maximum load on the network, it will be instrumental for some coordinators to run more than 4 workers, so that max cost transaction will be processed in time for the next block creation. If there are no coordinators running for any more workers, it will still be fine. It's just that the network will not be able to process as much as it potentially could at the moment of max load. But also 4 workers per coordinator is not a big constraint, and we do know that some coordinators run more than that number, like many times more than that number. So it is like a technicality, but a visible effect as well. So yes, enough of the snark worker optimization, but this will be delivered before the hard fork in one of the next releases. So yeah, let's talk about where this MIP is scheduled to be delivered. We are currently planning mass upgrade, and there was recently a post on X about that, but also we plan a blog post which will describe all of the changes that will be part of the mass upgrade of this hard fork. So this is a change, like this proposal is a change that we want to include in this mass upgrade hard fork as well. And preparation needed for us to be able to deliver this MIP is that snark worker optimizations need to be delivered as a preliminary release before we are able to deliver the slot reduction. And also we need to finalize the testing and validation. And we did run tests just for this MIP alone, but we'll need validation and testing not just for this MIP alone, but for all of the MIPs that come into the MESA upgrade. And for each of them individually, we did run some tests to validate that they will be fine. And we also have some formulas which estimate that everything, every subsystem of Mina will work all right when all of these MIPs are delivered as one package. But we'll need to run a test network with load test to just be completely sure about that our calculations were precise and there are no impacts which we didn't anticipate when preparing for this. And second thing that needs to happen is that infrastructure needs to be updated in a number of ways, and I'm specifically referring to infrastructure that is supported by community. So it's about block explorers, it's about how staking pools operate, and any other integration with Mina, which may rely on information that's blocks are created every 3 minutes or every 90 seconds. I mean, the slow time is 3 minutes or 90 seconds. So any such software needs to be updated. And we hope that all of such updates will be finalized and will be tested when we are doing the testnet testing. So like there will likely be at least one testnet just for load testing, and there will also be DevNet upgrade before this being delivered to mainnet. So we really hope that even if not before, then during the DevNet testing, infrastructure operators will notice any discrepancies because of this update, and they will be fixed before the mainnet launch. But just for the information of infrastructure providers, like this MIP doesn't introduce any other change except for that slot time is different. So the change shouldn't be extremely complex to implement for vast majority of the software related. So let's wrap up this talk with this and the next slide. And let's just kind of recap on the big picture. So when we deliver this slot reduction MIP, we expect that the cap experience will be better because blocks are more frequent, confirmation time is faster, so the cap transaction submitted gets like not approved, but kind of you can use information that it was included in the blockchain much quicker. So UX will be better for the users, and also you can send the cap transactions at higher quantities because throughput is greater, so that's cool. And also we expect that this MIP, especially when combined with other MIPs which are in the MESA upgrade, like all of them together will deliver a great and tangible improvement to how Mina operates. So a lot of use cases which were kind of possible on the paper, but were really hard to implement because of just a number of limitations that Mina blockchain has, should be enabled by the MESA upgrade. And this reduction from 3 minutes to 90 seconds is just one brick in this bigger building. And and finally, let's wrap up just about this MIP. So once again, it provides twice faster confirmations, twice higher throughput, and for ZK apps, it's actually 10 times higher throughput. Economics stays the same, and it will be delivered as part of the MESA upgrade. So thank you for listening, and now it's time for your questions.
Thank you, George. So if you have any questions, please put them in the chat or come on stage. In the meantime, you're racking your brains. I'll bring up some questions. These are from discussions which are on Mina research. So if you need any details, please feel free to hop onto there. So my first question was raised by Gareth. He had asked, does this impact the network propagation of blocks?
Yeah, this is a good question. So Yeah, of course it will impact network propagation of blocks because blocks are created twice as frequently. And also interestingly, if we consider other MIPs, blocks will actually be bigger than in the current blockchain. So we'll have twice more frequent blocks that are bigger than it previously was. So it will be impacted, but hopefully not will be impacted in a way that is critical to system maintenance and stability. So our observations were that networking layer was handling already the previous loads that were like possible with Berkeley, and that it will still be handling already loads that will be possible with the mass upgrade. So like there will be impact, but it will not be visible to users. And the biggest impact that users actually saw was not in networking layer, not in the network propagation per se, but just due to the fact that block processing was quite slow. So I mentioned that block creation and processing could take up to 100 seconds on certain occasions. So that was that could appear to someone observing that as a slow network propagation, because if you create a block and suggest this particular block was created in 20 seconds, but then you send it out and the next peer processes it for 100 seconds. It may appear to you as if network propagation was slow because the next peer on the network will receive it from the intermediate peer just 100 seconds slower. But that, like in many instances, when it could appear as a propagation issue, it was actually a block processing slowness, and we included a number of optimizations to dramatically improve that. So, yeah, our expectation is that the change, there will be some effect, but it will be measurable, but not really visible to the users or node operators.
Right, thank you. Ember is asking, any hope for another halving of the slot time ever?
Oh, that's a perfect question, Ember. And yeah, nice to see you again, Ember. Yes, let's talk about that. And by the way, this is not related to this MIP, it's about some future hub for anyone listening. So yes, it's definitely possible to cut this slot time even further. And it's quite manageable to cut it, I guess, until 20 seconds for sure, maybe even slightly lower than that. So like 15 to 20 seconds is sort of like, if we don't change other parameters like size of a block or like time it takes to create a block proof. Like there are a number of things which actually constrain how small we can go. Unless we change any of that, 15 to 20 seconds is like our current limit. So, but when I say the current limit, it also is not, we cannot cut it right away right now. So why so? The main obstacle right now is the networking layer. So I just mentioned a few seconds ago, a couple of minutes ago, that networking layer is not a source of concern for us for this particular MIP, or at least we don't expect it to be a source of concern. But if we cut it, for example, to 30 seconds or even to 60 seconds, the networking layer will start to be visible. And but that is not something fundamental. So the way we propagate blocks right now is imperfect. It is actually quite unreasonable how in Mina networks the blocks are propagated. And when I say quite unreasonable, it works well for the current setting. But we can do much better by implementing a number of networking, like a number of changes in the networking protocols. And these changes are understood, and some of them were actually prototyped at some point. So if we really want to reduce the slot time even further, we first need to deliver, like my opinion is that we first need to deliver these networking improvements. And because right now, you can think about it as you have 30 seconds to create a block, then 30 seconds for the block to be delivered and processed on your next peer, and then 30 seconds more for the next peer to process. And this will be like, for our size of the network, just these two hops is good enough to cover the whole network in the vast majority of situations. So yeah, and this rounds up to 90 seconds. But if we rewrite the networking, we can sort of say, have a situation where it's like just 30 seconds and a very small delta. So we could already go to like 45-second slot, for example. And maybe if we are just a little bit more smart, maybe we can go even lower than that. But this is still speculation. We didn't run experiments on that, but definitely possible. But it will be just a very different MIP, and a lot of things to say at the end of this journey. To just share with community about things that we had to look at or to tackle to get there.
Thank you, George. Thanks, Amber, for the question. I do have one last one. Does this change our finality time on the network?
Oh, yes, it does. So, like, what is finality time? Well, you can define different ways, but like from the user perspective, I would say that if you send a transaction, how much time you need to wait before it receives 20 confirmations, and 20 confirmations is that there is a block, and 20 blocks before this block, like in some grand whatever parent, this transaction lies. So by this definition, we just improved our finality 2 times. So if it was, I don't know the number for the current Mina network, not out of my mind, to get, for example, 15 confirmations. But whatever that number was, by delivering this MIP, it will be 2 times less. So the finality did change in a positive way, will change in a positive way when we'll deliver this MIP.
All right, thank you. I don't see any more questions in the chat. So thank you, George, for taking the time to present this MIP. Thank you all for joining. I do believe there's one more slide, and we'll share the slide deck with you all. So if you have any questions, you can reach out to us at either of these handles. And there's also a link to the MIP on Mina Research. So please feel free to surf on that too and leave your comments. Thank you all for joining. Have a great evening.